G'day guys, having a look at the algo force with the microscope because parts are so small you have to. Really difficult. But the other thing too of this, look at this, you say, oh, there's a part number there, but you got to tilt it to be able to read it. So yeah, LMC 662CM. So anyway, someone was asking, they want to know what the parts were under this capacitor here, under that one. And they said 3 parts. I think they're talking about the ones that I measured, and I replaced that one in the middle. And I have absolutely no idea what happened to that, because I had to look at the circuit. It goes through diodes, and it shouldn't have. Here we go. I think I've got that in focus. It's a lot better looking at this little camera thing than looking at it through the back of the iPhone. Tell you that. Anyway, what they are, they're just single diodes. They're high-speed, high-frequency diodes. And you can see the part number there, 5D. I think they're an on-semi part or a micro-semi, one or the other. And they're just single diodes. They're not joules or anything. So there's one there, one in the middle, one there, and some more over there as well. So if you have a look, they're all surrounding the AD797 input stage. So you can have a look there at the black things there in the middle, little black dots. They're resistors. There's a capacitor next to it, and you can see where the wires go, or the circuit tracks go under the chip. That's the feedback network to set the gain of that stage. So the more interesting things I was trying to find out here. We've got these little things here. I'll see if I can focus it a bit better. Oh, there we go. Little QFN packages, little thing with an I on it. I141Z FWVW, and 2 of them. Now, I'm having a look there where they are, and they possibly could go on to the AD797, do they? They might do. It's hard to tell because where the track's running, can't see a lot of them. So someone mentioned they might be current sense amplifiers, and it possibly may be, but I don't know. I had to look at, try to find those parts. I don't know what I is. That symbol, it's a manufacturer. Don't know. So there's 2 of them there anyway. And yeah, we get over here. Got that high voltage capacitor there too. That's what I'm looking at the moment. I'm just having a look there, the way this has got this heavy duty, just me kick the tripod, heavy duty PNP channel, just normal bipolar transistor in there. It does go to the coil. Now this thing uses, as far as I can tell, that's its output FET there. If you can read that, it's upside down, IRL 640 something or other. It's just a 200 volt MOSFET. See, like the parts on this, you got to actually, that's probably just a little op amp there. But you have to zoom in and use massive magnification to see anything. Everything's so small. But you can just sort of see the numbers on those parts there. Starts with a G, G1, I don't know. Better off measuring it. But let's have a look. What's that there? Down around you go. 3111 B984 LTHI. Yeah, I don't know what that is. No idea. That's the LCD connector for the display. Down here, got your microprocessor, MPU, whatever you want to call it. And there we go. That's a ADC sitting there. Whoopsie, around we go. You spin everything around to see it. Where was I? Oh, I didn't go there. I went over here. Oh, there. There we go. See the goop all over the board and on the chips? It's a resin and it's sort of settled in weird places. So there you go, AD7768-4. So I think it's a Delta Sigma quad input, 16-bit at a guess. I can't remember all the ADCs off the top of my head, but yeah, that's it. So yeah, have a look at it all. Great. Now, I did work out a few things on this. It has controlled current output to the coil, and it also has reverse, it looks like it some sort of reverse energy recovery straight into the battery circuit via that PNP transistor. So yeah, it's a good squiz with this. You can sort of see things quite clearly. You need to. A little power supply sitting there, a little op amp on it. How else? Can't read the numbers on the chips. That's probably some sort of looks like a regulator. That's definitely a regulator there of some description. Oh, can we see the number? No, it's under that stuff. It's upside down. But if you wanted to find out, oh dear, N something. Oh god, I don't know. Needs to be cleaned off. But yeah, you can just measure the what's going in, what's coming out. It's obvious telltale of those two capacitors decoupling on the input or output, because I don't know which one's which. Got no idea until poked and prodded. But the thing with this detector too is a lot of test points on it. All these little circles are test points. You can stick your crow probe in there and measure it. That one just there, not that one there. But I think that one there, that's the output of the AD797, that little circle. And there's lots of things you can test on this, and things that are adjustable that you do not want to adjust, do not touch, because you don't know what it does. So yeah, it's quite interesting. And that test point there, I'm pretty sure, yes it is. You can have a look at the information coming out of the analog digital converter there, and stick your probe on that, and it'll give you a data stream of highs and lows, or basically zeros and ones. You never make any sense of it, but yes, it's probably inputs and God, just trying to read the numbers of those chips. REF19S analog devices. Oh, that should be easy enough to work out. But yeah, the overall workings of this detector, it actually got me thinking, because if you have a look around the transmit stage, it doesn't have any flyback resistor. So it's doing an energy recovery, and a flyback is basically knocked down to 8 volts odd or something of that nature when I had a look at it. So yeah, it's throwing it back into the battery. And this brings up an interesting thought. Having a look at that, well, this is just an opinion piece, I've got to say that, but I was having a look at the 6000, GPX 6000, and I looked on that too. I've had a good look everywhere on that thing, and it doesn't have, as far as I can tell, right, it doesn't have anything resembling, flyback damping as such, unless it's done in that black module and it's so prying eyes can't see, or it's some other way of doing it. Maybe they've got a big PNP transistor in that black module and doing energy recovery. But whatever's in the black module, they don't know. They obviously don't want anyone to see what it is. So that's the crux of the matter there. overly complicated and, in my opinion, overly engineered, but seems to work quite well. Anyway, about this, I'll get off this magnification bizzo. I don't think you're going to see that much. Yeah. So this little detector, just make this turn off. Goodbye. Love the way it does that. Goodbye. Sayonara. Yeah. On a little circuit, even though it's very, very small, it seems quite interesting. And I had it on the oscilloscope looking at the pulses and everything and trying to just nut out what's going on this gadget. And the more I look, yeah, there's some things, well, I'm not going to be negative. I was going to say the more I look, the more I'm intrigued. So I'm quite very, very intrigued. I just realised then there's that IC down there. It looks like it's got a 2.4 or so strip line type circuit board antenna on it. So obviously it's got some sort of RF connectivity, be it Bluetooth or whatever it is. Again, I haven't looked at the chip number, I don't know. But yeah, I'm starting to take a bit of a fancy to this design. I think it's more to it than meets the eye. I'm going to do some more tests. But I did some initial testing with ground balancing and really trying to confuse it. I tried my hardest to confuse this thing and see if I could obscure tiny gold from it. And it had no problem whatsoever. Target moving with super hot collection of hot rocks doesn't care less. Without doesn't care. And the ground tracking is really fast. It's instantaneous. I just had a quick read of the instructions. It's got a lot of functions on it. So there's all sorts of modes and all sorts of wonderful stuff. So I'm going to have a bit more of a play with it anyway. It's very hard to get, if you want to go and nut out all the pinouts on the CPU here, it's a good chance you'll short 2 pins out and blow it up. So that sort of stuff's problematic. It does have test points around here, those little gold things there, 3 there. What they are, I don't know. You have to measure it and try and make a logical assumption as to what is going on. But the way I suspect this gadget works, and these here, maybe those 2 little ones there, maybe current sense amplifiers. I'm not 100% sure. I have to do some more testing. But from what I look at, they're basically doing energy recovery, and they're also, doing something with exponential pulse as well. And all this together mitigates a lot of the flyback voltage and moves it off. And because if they keep the transmit current very, very steady or controlled and they know where it is, this actually is utilized for a very good way of discrimination above and below the flyback curve. Because you've got control over what you're getting back, you know what you're looking at, rather than a lot of people trying to do it and just guessing it and getting it all up what creek. So yeah, at first I thought it was a bit of a toy. I did. I said, oh look, God, looks like looks like a GM 1000 a little bit, the same sort of overall layout, and a little bit like that, the other thing, the Algo, but that's got normal DMods in it using capacitors, so it's not as up there as what this is. This is definitely using a quad channel ADC in it, and yeah, I'm sort of a little bit intrigued. and slightly on the verge of being a little bit impressed. So, but more needs to be done. And yeah, even though someone sent me a big list of faults that they've discovered with these detectors, and I don't know if it's just I don't know what the faults are. To me, I have my suspicions to what's causing a lot of uh, erroneous type faults where they say the detector will start screaming for no reason, stuff like that. And yeah, I've done some initial measurements on areas I know what's going on, but I think there is some room for a little bit of improvement. I'm not saying it's like bad engineering or anything like that. It's just that uh, I sort of, have a real niche at finding out certain things about what happens where under what circumstances, and yeah, we can get in there and probably have a sniff around, see what if there's any instability at all. I don't really know, but my initial testing says this is a damn good detector. And if it does have these funny little faults there, if you read the forums, everyone's having a whinge. But I think whatever's happening, I think it's probably very easy to take care of, um, if it really is. It might be a coil problem. Might be someone did say that the coils don't have any shielding as such, that they run the cables as a twisted transmission line down to the coil. Funny about that. But yeah, is that it? And it gets near metal or something? I don't really know. I don't really know, because to actually work this out, you'd have to sit there on the bench for about maybe 2 or 3 weeks and solid. I mean, 8 hours a day at least, and try and nut this thing out. It would take a hell of a lot of time. Or if you really wanted to, you send it off to that Chinese company that reverse engineers stuff. Um, someone, someone actually, I'll tell you, someone actually did that, and they sent something detector-wise into this Chinese company, and uh, he said, "Can you reverse engineer the whatever it was?" And they actually did. They reverse engineered it. And I'm not joking. As a functional unit, work that one out. So yeah, that's sort of. I think it's what's it called now PCB. Read up on it. It's on the internet. Now PCB. Um, they reverse engineer all sorts of stuff. They'll yeah, I don't know. Send them a 6,000 call. See if they reverse engineer the encrypted chip. I doubt it. That thing is basically bulletproof, as far as I can tell. I did read up a lot on that, and it does take physical attributes um, of the individual ICs and incorporate that into its coding algorithm. So work that out. No two chips are the same. So that could be interesting. Anyway, that's this Garrett thing. It's like not many people know anything really much about it. They're going to all having a rough stab at this, that, and the other. But yeah, talk about it's just small, and you compare it to the other detectors that are very, very large. Especially, I'm talking PI. In general, they are coming down in size as we've seen other detectors hitting the market. They are smaller, all full of QFN little packages, um, and similar. Very hard and difficult to work on because it's so damn small. I mean, you look at that. You know, well, just for instance, say if I do that, and I say that little chip there in the corner. Uh, if you look at all the legs on that, you say, "Oh, it's got a dry joint. Touch it up." you know, you don't have a soldering iron small enough to do it. You're gonna have to do you know, a uh, a flux solder mix and hot air, and yeah, hopefully you don't burn it to a crispy. Uh, Trying to resolder stuff like that, because then you use hot air. What happens? All the parts around it, you blow them off the board if they get hot. Um, it's very difficult to do this stuff. You got to use little heat shields and all sorts to cover componentry you don't want to get hot. So yeah, that's the fun and games of all this microelectronics. It is fairly small. The only thing they can't shrink is the connector and electrolytic capacitors. Um, yeah, they sort of are what they are. So yeah, even that there, it's a 470 microfarad. The other thing of intrigue is all the little variable adjustments on it. For fine tuning, I'd take it. But yeah, if anyone ever found a service manual for one of these, it'd be very intriguing to have a read up on. So that's it there. That is what it is. Like I say, I could suggest a few things for the board layout, but I'm not the guy who designed it. Knows what he was designing, and you probably wouldn't like it if someone said, "Oh, you should have done this or you should have done that." Just me, I would have done a few little things different, which I can see, but yeah, each to their own. But it is an interesting sort of a build, isn't it? Very, very small, tiny. As in most of these things now, most of the work's done over here, and yeah, the rest of it's just general IOs and housekeeping. So very interesting, isn't it? Very interesting indeed. So I'm not going to waffle on about that, but I just giving my thought about it. So yeah, to that fellow, if those things are what you wanted to know about, those three little things you said under, I hope you don't mean there's parts under the electrolytic. Um, wouldn't that be funny if he said, "Oh, parts on the three parts under the electrolytic," and that they're actually under it between the legs? Nah, 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 no. It's on the board hard. That'd be a laugh, wouldn't it? Imagine that as parts under that. Wouldn't surprise me these days what people do, but no, there's no room. Can't be. Um, yeah. Now that I said it as he wrote it, I'm quite intrigued. Does he mean that? No. You're talking about those three things there, aren't you? Well, actually, one, two, three, four, five, six. They're all just high-speed signal diodes. Something about point two or 0.3 of a volt drop uh, at operating voltage with very, very little current through them. So that's that. Um, all good. All good. Anyway, the rest of it's going to be waffle on if I keep waffling. So, yeah, you need one of these things to have a look at it, unless you've got little beady eyeballs that can see those tiny, tiny parts and yeah, read the numbers off them. I mean, you just stare at it, you got to get so close in your face. But anyway, it's enough of that. Catches.